Hello everyone, in this video I explain the substitution method that we have done already. So I'll explain it briefly. So let's try to do this problem using what we already know. So integral of cosine x squared times 2x dx. So we can easily do this if we remember that the derivative of sine x squared. So let's think about what the derivative of sine x squared would be. So that would be cosine x squared, and since we have a different variable here, so we're going to use the chain rule. So times derivative of x squared, which is 2x. Thus we have derivative of sine x squared is equal to cosine x squared times 2x. Since we know that integration and derivative, they are inverse processes of each other, so from here we get, so this means integral of cosine x squared 2x dx would be equal to sine x squared. So we were able to do this example using our knowledge about derivatives. And one thing we are noticing here is what we are really doing is we are reversing the process of chain rule. And of course, in case of indefinite integrals, we always do plus c. Let's do a bit of analysis of this problem. So what we had here is, so we had cosine of some expression and we had the derivative of that expression. So expression and its derivative. And we were able to figure out the integral. So let's take a look at the next problem and see if we analyze something similar there as well. So in the next problem, I have just rewritten the problem, and we can see that we have cosine of x plus x cubed, and outside we have 1 plus 3x squared dx. So if we compare this with our previous example, so we see the similar structure here. So we have an expression inside the function, so expression, and then we have the derivative of that expression. By comparing this with the structure of previous example, so I suspect that the answer should be sine of x plus x cubed plus c. Let's say if we have done it correctly or not. So we can always verify it. We can always take the derivative of this expression and see whether that is equal to the given expression. So let's try that. All right, so for the verification, I'm going to take the derivative of sine of x plus x cubed, and I know that the derivative would be cosine of x plus x cubed, and by chain rule, since we have a different expression here, so we need to apply the chain rule. So we need to take the derivative of x plus x cubed again. So what we get here is cosine of x plus x cubed multiplied by 1 plus 3x squared. So this verifies that what we did in the example to evaluate the integral is correct. So thus from these two examples we can create a generalized formula for the substitution method. And the substitution rule formula looks something like this. So let's try to analyze the structure of this formula. So we have an outside function, which is our f. Then we have the inside function, which is our gx. And we have the differential of inside function. So here u is equal to gx. So basically we can start with the left hand side of the function and we can substitute. So let u is equal to gx. So, and then what we do, we try to also find the value of du, because if I just do this, so I get here f of u. So what about the last expression g prime x dx? So we need to convert everything in terms of u here. So we're going to take the differential of u. So we get, or you can say that we to take the derivative, we get du over dx is equal to g prime x, and du is equal to g prime x dx. So it means we can replace this whole expression by du. So substitution method is also called the so-called reversing the chain rule for derivatives, and it's used when we have an integral that contains some function and its derivative. So next we're gonna discuss the different steps that we use in the substitution rule. So step number 1 is, so we choose the new variable u, and then we figure out the value of the differential of u. And in third step, we make the substitution. So this is very important. At this step, you should get rid of the original variable. So for example, if you have x in your original function, so you should get rid of all the x's at this step. Then we integrate the new resulting integral, and in the end, we put back the answer in terms of initial variable. Let's do some next few examples, and we're going to use all these steps that we discussed here. So for example, if we start with this one here, so secant square x for 4x cubed dx. So we have to find the derivative of this expression. First thing we notice that we are given x4 here, and also we have the derivative of x4, which is 4x cubed. And if you do the substitution, let u is equal to x raised to power 4, so it means you can take the derivative of both sides, so we get 4x cubed. So from here we get du is equal to 4x cubed dx. So if we look here, so we can do the substitution now. So we get secant square, in place of x4 we write u, and then 4x cubed dx. So this whole thing is our du. So we get du. And previously we learned that integral of secant square x dx is equal to tangent x plus c. So we can use that here, and we will get tangent u plus c. So that is our fourth step, because we did the integral already. And the last step is you put back the answer in terms of initial variable. So we can again get everything in terms of x. So let's substitute back the value of u, so which was x raised to power 4 plus c. So that is our answer. So in the next example, again, first we choose our variable. So inside the function, so inside we have 3x squared plus 7. So we choose our new variable in the first step. So first step is let 3x squared plus 7 is equal to u. We did this because we noticed that if we take the derivative of x squared, we're gonna get a power 1 of x, right? So it means even though explicitly we are not given the derivative of this expression, but we can make it, because in your mind you can think of derivative of 3x squared is 6x, and if you have x, it's easier to make 6x because you can just multiply and divide by 6. So that's how we decide what substitution we need to make. And then we need to find the value of du. So du over dx would be 6x plus 0, which is just 6x. So from here we get 6x dx is equal to du. But here we don't have 6 anywhere, so it doesn't matter. So what we can simply do here is we can write what should be our dx. So dx is du over 6x. And when I try to plug in all these values in my given integral, so I notice that, so what we get here is integral of cosine of u, and then let's keep x as it is, and in place of dx we write du over 6x. So we plugged in this value and we plugged in this value. And at this point we notice that still we have some x's here. So we cannot proceed. So still we have combination of x and u. So we need to get rid of all the x's, and we can notice that x gets cancelled. So what we have here is essentially cosine of u du, and 1 over x, which is just a scalar constant, we can bring it outside the integral. So now we can proceed with solving our integral, and we know that integral of cos x dx is sin x. So in this case, integral would be, the integral would be 1 over 6 sin u plus c. And in the last step, plug in back the value of u, because we have to give answer in terms of our original variable. So now we have sine of 3x squared plus 7, which is our u, over 6 plus c. So remember, we apply the substitution rule when we have an integral which contains a function and its derivative. So we have a function between the function and the derivative of the function. And if you just do the substitution carefully and follow all the steps, you will get the correct answer in the end.